Could Proxima b be another Earth-like planet? These are speculations everyone keeps making. The search for an alternative habitable planet and alien life on other planets is something that humans are fascinated with. There have been various speculations, and the fact that there have been signals coming from Proxima b makes people believe there is more to it. Despite all these signs, we have yet to determine if these are messages from the planet or just echoes of our own signals. Often, these signals end up as ghosts in the search for alien life. Scientists hope to determine if alien life exists by finding out whether these signals are truly from Proxima b. Recently, the James Webb Telescope detected artificial lights on Proxima b. If you're interested in learning about other planets and our progress in finding alternative life, subscribe to our channel. We create content about outer space and discuss innovations in science. If you like this content, comment below and share this video with your friends. Now let's go back into our video. Proxima Centauri, about 4.2 light-years from our solar system, is a faint dwarf star classified as a G-type. Thus, the star is known as Proxima Centauri. It is the closest star to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603, based on the star's ascension at noon while several celestial bodies, like the Moon and the Sun, were in a straight line. Proxima Centauri is also known as Alpha Centauri A or Alpha Centauri. It is a single star system with 4 main stars in a line. Proxima Centauri is at the center of the system. Apart from the 4 stars, there are 2 faint dwarfs, Alpha Centauri B and Alpha Centauri C, which make up the bulk of the mass but are too faint to be seen by the naked eye. The system is located 23 degrees away from the border of the famous Plough asterism in the constellation of Centaurus. Even though Proxima b is a rocky planet, there is still hope that it might have extraterrestrial life. The search for any other life out there has brought scientists to Proxima b. They believe the similarities to Earth's size and its distance from its dwarf star make it a viable option for planets that could accommodate life. While all these are speculations, there is hope that there might be some truth. There is much to learn about Proxima b and the orbit it takes, so stay tuned to find out more. You can also check out some of our other content related to extraterrestrials. Do you really believe there's life out there? Leave a comment down below. What fascinates most people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star. Its mass is considered to be 1.27 times that of Earth. Proxima b takes 11.5 days to complete an orbit around its star. It was discovered in 2016, and many scientists are looking into it. Even though Proxima b looks similar to Earth, certain features make it uninhabitable. For one, the planet is too close to its star, which means it receives extreme ultraviolet radiation from the star. It is estimated to be hundreds of times more than the radiation we get from the Sun. This radiation is so strong that it strips away even the lightest hydrogen molecules over time, doing the same to oxygen and nitrogen. While most people might argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to it than meets the eye. Distance does not consider whether there is water on the planet, nor is there any evidence of an atmosphere conducive to living things. The atmosphere on Earth is what makes it habitable, and not Mars. The right atmosphere allows for climate regulation and a water-friendly surface, shielding living organisms from hazardous space weather. If you're with us so far and haven't subscribed yet, take a second to hit the subscribe button. It makes it easy for us to keep creating content like this that you'll love. Now, let's look at why people think that the James Webb Telescope will help us figure out if there is life on Proxima b. The James Webb Telescope was launched in 2018, after being delayed since 2011. Many changes had to be made to ensure it provided accurate images. During production, scientists explained that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb Telescope was specifically designed to observe infrared light. It can take photos of this light on the surface of a planet and look for patterns that might confirm if the planet has water or an atmosphere. One of the reasons why space telescopes are preferred over ground-based ones is that by being above the atmosphere, they don't have to peer through the shifting air to see deep into space. Therefore, they get a better view of what goes on outside the solar system than most ground telescopes can achieve. Another advantage is that weather changes on Earth do not affect them, ensuring astronomers get clear readings. The only downside to having a space telescope is that fixing it can be expensive. If something goes wrong, there have been cases where a small flaw in a space telescope required a whole mission into space to fix it. Such costs make observing planets like Proxima be difficult. With the James Webb Telescope, we have no option for rescue. It has been launched over 1.5 million kilometers away, further than any human has ever traveled, so rescue missions are not an option. The James Webb Telescope comes with a larger mirror, which allows us to see back to the beginning of the universe, almost 13.7 billion years ago. The further away an object is, the further back in time we get to see it. This is because it takes a while for the light to travel from an object back to us. The ability of the James Webb Space Telescope to observe the universe in longer wavelengths, in infrared light, means we can see more distant galaxies in our universe with greater certainty than was previously possible. Therefore, observing planets like Proxima b has become easier, as it has pushed the light out of the visible range and into the infrared. Tabor and Loeb have developed a scale of artificial illumination as a fraction of how the sun illuminates and reflects on the day side of the planet. At 0% on the scale, one would assume that the planet's night side is completely dark with no illumination. At 100%, it means that the planet's night side is just as bright as the day side. There has been a hypothetical civilization on Proxima b using this type of light, and most scientists believe it is similar to the early days on Earth. Studies show that if the night side of Proxima b reaches an illumination of 5% of the natural day side, then the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope would detect up to 95%. Even though 5% illumination sounds like a small number, we're talking about the light from a star as far away as Proxima Centauri. Compared to our Sun, we have an illumination that is 20,000 times dimmer, yet we still have a lot of light from our star. This means that at 0.1% of illumination, we are still reflected in the stellar illumination. In other words, if Proxima b has any civilization disguised by glowing like Earth, the James Webb Telescope would not detect it. The stars would need to be about 500 times brighter. This scenario is impossible since Proxima b orbits so closely to its host star. There is a chance that it might be tidally locked, meaning one side of the planet always faces the star while the other is in perpetual night. A civilization living on a tidally locked planet might need to focus on illuminating infrastructure and use very bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. All these are speculations made by Tabor and Loeb, and there is yet to be proof to show that they are true. Earth's illumination can be seen from outer space and is known as airglow. Most people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. The airglow happens when atoms and molecules in the upper atmosphere produce light to release excess energy. On Earth, airglow can occur when atoms and molecules get ionized by sunlight and capture free electrons. The glow seems similar to an aurora, except that auroras are driven by high-energy particles from the solar wind. The airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, scientists have been asking whether it is sufficient to view other planets in faraway galaxies. Even though it is the furthest satellite telescope launched, it still provides very little data needed to find planets with life in other galaxies. As such, there have been conversations about developing bigger and better telescopes. These ventures are often costly and involve a lot of trial and error. The James Webb Space Telescope's launch was 7 years late due to these issues. Therefore, it is challenging for most scientists to develop better innovations that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising. Soon we might know if there is life on Proxima b and other planets. While work is still being done on more telescopes, it is believed that the completion and launch of the Habitable Exoplanet Observatory, HABEX, will revolutionize space study. The estimated completion time for HABEX is 2035, with a launch soon after. HABEX will be sensitive to all planets in the universe, and its main objective is to search for Earth-like planets. Its advanced technology will enable it to measure the spectra of most planets, providing insights into the atmosphere's composition. Since Proxima b is nearby, It is one of the first objects that HabEx will analyze. The launch of the Louvre telescope will further enhance our knowledge of our atmosphere and that of Proxima b. It aims to help us identify what makes Earth unique and whether Proxima b shares similar traits. While HabEx and Louvre are not the only space telescopes in development, they are expected to be some of the most advanced. Currently, there is promising news from the analysis of the atmospheres of 28 Earth-like planets, with some showing traces of water vapor. If our understanding of Proxima b continues to grow, we might even find a biosignature indicating life, which would provide further insight into life on distant planets. The ongoing advancements in astrobiology and planetary science keep the excitement surrounding Proxima b alive. Researchers are investigating the planet's geological features, climate dynamics, and potential biosignatures. Collaborations among astronomers, geologists, and biologists will be crucial as we refine our search techniques and hypotheses regarding Proxima b. The quest to explore the cosmos and uncover the mysteries of life beyond Earth is ever growing. If you want to stay updated on the latest developments in the search for extraterrestrial life, subscribe to our channel for weekly updates, including telescope reviews and investigations into Earth-like features on other planets. The fascination with Proxima b stems not only from its proximity to Earth, but also from the intriguing questions it raises about habitability. As scientists study this exoplanet, they are employing a variety of advanced techniques to uncover more about its atmospheric conditions, surface features, and potential for supporting life. Researchers utilize models of climate systems to simulate the possible weather patterns on Proxima b, taking into account its unique orbit around a red dwarf star. Understanding the star's emissions is critical since M-type stars like Proxima Centauri emit light differently compared to G-type stars like our Sun. This distinction affects how heat and energy are distributed on any orbiting planets. Because Proxima b is so close to its star, there is a possibility of experiencing significant tidal forces, potentially leading to geological activity such as volcanism. Such activity could create conditions suitable for life, should there be any form of liquid water. In addition, astrobiologists are actively exploring extremophiles, organisms that thrive in extreme environments on Earth, as analogs for potential life forms on other planets. By studying these resilient creatures, researchers gain insights into how life might adapt to harsh conditions, such as high radiation levels or extreme temperatures, which may be present on Proxima b. This understanding broadens the scope of where scientists might look for life beyond Earth, including seemingly inhospitable environments. The role of public interest and funding in space exploration cannot be understated. As awareness grows about the potential for life on exoplanets, so does the push for more resources dedicated to space missions. Citizen science initiatives and public outreach programs help engage the community and generate support for missions aimed at discovering extraterrestrial life. Public interest can lead to increased funding for space agencies, enabling the development of more advanced technology and telescopes that will enhance our ability to explore distant worlds. In parallel, advancements in artificial intelligence and machine learning are revolutionizing how astronomers analyze data collected from telescopes. These technologies can sift through vast amounts of information, identifying patterns that may suggest the presence of biosignatures or other indicators of life. This synergistic approach combines traditional scientific methods with cutting-edge technology, maximizing our potential to discover life beyond our planet. Furthermore, international collaborations are increasingly becoming the norm in space exploration. Many countries are pooling their resources and expertise to tackle the challenge of interstellar research. This cooperative spirit enhances our understanding of the universe while sharing the risks and costs associated with deep space missions. As scientists continue their quest to answer the age-old question of whether we are alone in the universe, the emphasis on multidisciplinary approaches becomes crucial. Insights from chemistry, biology, geology, and physics will shape the future of astrobiology and our understanding of exoplanets like Proxima b. The journey of discovery is ongoing, and each new piece of information brings us closer to understanding the potential for life beyond Earth. As we explore the cosmos, our own existence takes on new meaning, and the search for extraterrestrial life remains one of humanity's most profound endeavors. As we await news about the potential existence of life on Proxima b, The quest for knowledge continues, fueled by our collective curiosity about the universe and our place within it.